Hello and good day. Welcome back to our class. This is teacher Onin Guzman, and our topic for today is proving the conditions for similarities of triangles. Specifically, we will talk about the side angle side, side, angle, and angle similarity theorem for grade 9, quarter 3. The use of similar triangles is extremely important where it is beyond our reach to physically measure the distances and heights with simple measuring instrument. Still, there are many applications that are beyond our knowledge where simple concept of similar triangles can create enchanted consequences and influence in that particular area to a great extent and aid us to create a greater extent when we try to explore something new. The question is there a way we can measure tall structures and difficult to obtain lengths without using direct measurement? How are sizes of objects enlarged or reduced? How do we determine distances between two places using maps? In short, how do concepts of similarity of objects help us to solve problems related to measurements? You will be able to answer this question by studying this on similarity in geometry. So the first theorem that we will have is the AA similarity theorem. Stress that if two angles of one triangle are congruent to the other two angles of one another triangle, then triangles are similar. To demonstrate this, let's look on the illustration on the right side, such that AD intersects BE. So this is the line segment AD intersects line segment BE at point C, as well as AE is perpendicular to BE. Also, BD is perpendicular to DA. So we would like to prove that BD over CD is equal to AE all over C. For our proof, we will use the two-column form. So for our statement number 1, we have AD intersect BE at C. The reason is given. For number 2, we have angle BCD is congruent to angle ACE because of vertical angles are congruent. For number 3, we have AE, line segment AE is perpendicular to line segment BE, as well as line segment BD is perpendicular to line segment DE. The reason is given. And for number 4, angle BDC and angle AEC are right angles because perpendicular lines form right angles. To continue our, we have statement number 5. Angle BDC is congruent to angle AEC because right angles are congruent. For number 6, line segment AE is perpendicular to BE and BD is perpendicular to DA because AA similarity theorem. And finally, we have BD over CD. So BD over CD is equal to AE over CE because we have the definition of similar triangles. So let's move on to AAA similarity theorem. Stress that if three angles of one triangle are congruent to the other three angles of another triangle, then triangles are similar. So let's look on the illustration on the right side. So we have triangle ABC as well as triangle XYZ. So we have given the angle A is congruent to angle X as well as angle B is congruent to angle Y. So let's mark this. Again, so we have angle A is congruent to angle X. As well as angle B is congruent to angle Y. Also, we would like to prove that triangle ABC is similar to triangle XYZ. So for our proof, our statement number 1 is angle Y is congruent to angle X because it's given. For number 2, we have angle B is congruent to angle Y. So again, from our markings, so we have actually from our given. For number 3, we have angle A is, or the measure of angle A is equal to the measure of angle X because of the definition of congruent angles. For number 4, the measure of angle B is equal to the measure of angle Y. Again, we will use the definition of congruent angles for our reason. To continue, okay, we have the measure of angle A plus measure of angle B is equal to the measure of angle X plus measure of angle Y. The reason is we use the addition property of equality. So in fact, we add statement number 3 and number 4. Number 6, so we have the measure of angle A plus measure of angle B plus measure of angle C. So we have again, this is the illustration. We have angle A, angle B, angle C. If we will add this is equal to 180 degrees. As well as the measure of angle X, angle Y, and angle C is equal to 180 degrees because of the sum of the measure of the interior angles of a triangle is 180 degrees. For number 7, the measure of angle A plus measure of angle B plus measure of angle C is equal to the measure of angle X plus measure of angle Y plus measure of angle C because we use the transitive property of equality. Moving on for statement number 8, we can have the measure of angle C is equal to the measure of angle Z because we use the addition property of equality. Okay? For number 9, we have angle C is equal to angle Z because of the definition of congruent angles. So therefore, we can say that triangle ABC is similar to triangle XYZ because of AAA similarity theorem. The next we have is the side angle side or SAS similarity theorem. So given a corresponding between two triangles, if two pairs of corresponding sides are proportional and the included angles are congruent, then the two triangles are similar. So let's look on our illustration on the right side. So we have triangle XYZ is similar to triangle ABC. So the ratio of XY all over AB is the same as the ratio of XY all over AC. And angle X is congruent to angle A. So let's mark that. Alright. So we would like to prove that triangle XYZ is similar to triangle ABC. For our statement number 1, so we draw RP such that XR is similar to AB and XP is similar to AC. And the reason is by construction. So again, we draw here a line segment RP. Number 2, we have angle X is congruent to angle A because that is given. Number 3, triangle XRP is congruent to triangle ABC because side angle side congruence theorem. For number 4, XR is congruent to AB, then XP is congruent to AC because corresponding parts of congruent triangles are congruent. On for statement number 5, we have the ratio of xy all over AB is the same as the ratio of xy all over AC because we have that is the given. And number 6, xy all over xr is equal to xz all over xp because by substitution. So again, so this is xy all over xr, the same as, okay, xp or xa all over xp by substitution. So we can say that RP is parallel to YZ because converse of basic proportionality theorem. For number 8, so angle XRP, so angle XRP is congruent to XYZ because if two parallel lines cut by transversal, corresponding angles are congruent. For statement number 9, angle X is congruent to angle X because we have the reflexive property of equality. For statement number 10, we can say that triangle XRP is similar to XYZ because AA similarity theorem. And finally, since X or triangle XRP is congruent to triangle ABC, so we can say that triangle XYZ is also similar to triangle ABC because of transitive property of equality. Alright, so let's move on to the side-side-side or SSS similarity theorem. Stress that given as correspondings between two triangles, if three corresponding sides are proportional, then the two triangles are similar. To illustrate that, let's look on the triangles on the right side. So we have triangle PNR is similar to triangle MST such that PR over MT is the same as Pn all over MS is the same as Rn all over Ts. So we would like to prove that triangle PRN is similar to triangle MTS. For our proof, we will have statement number 1 that x and y be points on PR and PN respectively such that PX, where's the PX? PX is equal to MT and PY is congruent to MS. So we have by construction. And number 2, Px is equal to Mt and Py is equal to Ms because that is congruent segments have equal measures. For statement number 3, so we have PR all over Mt is the same as Pn all over Ms, which is the same also as Rn all over Ts because that is from our given. Number 4, PR all over Px is the same as Pn all over Py because we use the substitution. Okay, take note that Px is equal to Mt as well as Py is equal to Ms. Moving on, for statement number 5, we have angle P is congruent to angle P because we have the reflexive property of equality. So we can say that triangle PRN is similar to triangle PXY because we have the side angle side similarity theorem. For statement number 7, xy all over Rn is equal to px all over pr. That is definition of similar triangles. For number 8, we have xy. We have xy all over Rn. This is the same as mt all over pr. We use the substitution such that px is equal to mt a while ago. Let's continue. For statement number 9, we have xy is equal to Rn times mt all over Pr as well as Ts is equal to Rn times mt all over Pr. We use the multiplication property of equality. For number 10, we can say that xy is equal to Ts. We can factor this one out since Rn times mt all over Pr or is the same as this expression also. So we use the transitive property of equality. For statement number 11, we can say that triangle PXY is similar to triangle MTS because the SSS similarity theorem. And finally, We have triangle PRN is similar to triangle MTS because of transitive property of equality, specifically for our statements number 6 and number 12. Okay, for the application, let's consider the triangle on the right side. So we have triangle TBI is similar to triangle LMT. So give the indicated measure. So let's concentrate first on the given angle. So take note that measure of angle B is equal to the measure of angle M because they are similar. So we can say that measure of angle M is also 95 degrees. Next, measure of angle T is equal to the measure of angle L. So we can say that the measure of angle T is equal to 25 degrees as well. Next, take note that the measure of angle T plus the measure of angle B plus the measure of angle I is equal to 180 degrees because the sum of the interior angles of a triangle is equal to 180 degrees. So we can simply substitute the measure of angle T is 25, measure of angle B is 95, and we want to find out the measure of angle I. Simplifying it further, so we can say that the measure of angle I is simply deduct both sides of the equation by 25 and 95, so the measure of angle I is equal to 60 degrees. Since we can say that the measure of angle I is also the measure of B, so this is 60 degrees. So which is also the measure of angle T, which is particularly that is T, which is also 60 degrees because take note that triangle TBI is similar also to triangle LNT. On the other hand, if we would like to find the measure of line segment TI, we can use the ratio of TB all over Ti is the same as Lm all over Lt. So let's substitute the given. So Tb is equal to 27, Ti is equal to unknown, while Lm is equal to 18, and Lt is equal to 36 from the illustration. Using the cross product, I can have 27 times 36 is equal to 18 times Ti. Then divide both sides of the equation by Ti. So Ti is equal to 54 units. On the other hand, I can use also the others ratio such that Ib all over Ti is the same as, okay, Tm all over Lt. Substitute. So we have 18 over Ti is the same as 12 over 36. Using the cross products, so we have 18 times 36 is equal to 12 Ti. Divide both sides of the equation by 12. So Ti is the same as 54. As you can see, okay, whatever ratio we will use from the given similar triangles, we can come up with the same value of Ti. So Ti is 54 units. So let's move on to problem number 6. So pole 3 meters high has a shadow of 5 meters long with a shadow of a nearby building is 110 meters long. How high is the building? So for our representation, we will let x is equal to the height of the building. So sometimes in order to solve the problem, we need to sketch or to draw the problem. So say for instance, this is the building and the height of the building is unknown. So we will represent that one as x. And the shadow is equal to 110 meters. So say for instance, this is the shadow, which is 110 meters. On the other hand, there is a pole, and the height is 3 meters. And the shadow is equal to 5 meters. So from this, we can create now the ratio and proportion. So I can have the height of the pole over its shadow, which is the same as the height of the building all over its shadow. So we have 3 pips is equal to x all over 110. Now, using the cross products, I can have 3 times 110 is the same as 5 times x. Solving for x, divide both sides of the equation by 5. So I come up with x is equal to 66. So therefore, we can say that the height of the building is 66 meters. So that ends our topic on proving the conditions for similarity of triangles. Again, so this is Teacher Ono de Guzman. Do not forget to subscribe to my channel so that you will be notified about my new videos. Thank you.